Assalamualaikum, IB to all examiners. I am Nurin Syafiqah, Group Leader for Final Year Project entitled Comparison on Service Offered by Two Online Shopee Vendors during MCO using Single Channel Multiphase Queuing Model. My team members are Aeisyah Nadhirah and one Aeisyah. We are supervised by Madam Norsaadah, Awang alias Mohd, Amin.
As for introduction, there are 3 key points that has encouraged the researcher to conduct the study. The first one is online shopping. As we all know, the popularity of e-commerce sector has significantly growing before and even after the COVID-19 cases has risen since people start normalizing using online platform for shopping. So, what is online shopping? Online shopping is the activity or action of buying product or services over the internet. The second one is movement control order. Due to this implementation, humans' activity are limited, and because of that, people are switching their shopping pattern into online shopping platform, which is way more convenient for them. The last important key is the queue. Some people may find switching to online shopping has solved their problem. However, little did they know the queue is also happen in online platform. Queue usually happen when a lot of people buying the same product at the same time, and queue also can happen at the courier service deliveries since the number of deliveries skyrocketing during MCO. So with these 3 key points, the researcher find the interest to study on the queue that happen for vendor who run their business by themselves and their service performance. Thus, the researcher proposed 2 data from 2 different vendors in FM industry to study and compare the service offered by them during MCO by using single-channel multiphase queuing model.
The problem based on application is the long shipping time makes online shoppers feel frustrated and decided to buy goods at a shop rather than buying online. For problem based on the method, fuzzy queuing model is proposed in this study because it is for multi-server channel, while simulation model is too complex for real-life problem. Therefore, this study proposed single-channel multi-phase queuing model as a method. Our research is aiming to measure the customer average waiting time for 2 online Shopee vendors and to determine the best vendor that gives the best service to the customer using t-test.
The method that has been used in this study is single-channel multiphase queuing model. This study helps researchers to have better understanding. This is because study based on online shopping have rarely done before, since people assume that queuing theory is only applicable whenever there is a queue. Through this study, the researcher also able to understand more detail about the queuing theory that is applied in the real life. This study is focused on waiting time of 2 online shopping vendors, which is this study use secondary data that was obtained from 2 online shopping vendors who sell the same type of product but different brand, which is one of the vendor run names Chocoja business while another one Melo Crunch. The collection data has been set at a certain period of time, which is during MCO on May and June 2021. Due to COVID-19, the limitation of the study is difficult to obtain the data.
So, what is single-channel multiphase queuing model? For your information, queuing system was developed by Erlang, a Danish mathematician in 1904. According to Walku, queuing theory is a field of probabilistic and stochastic model in providing workable solution of queuing problem. There are various queuing models, but for this research study, the researchers applied single-channel multiphase queuing model since the data were collected from 2 single vendors who run their business by themselves, and the customer order has to go through multiple servicing processes before they receive it. And according to Hazel and Render, there are 3 main components involved in queuing system, which are arrival, queuing discipline, and service.
Single server channel has been widely used in the application of heavy traffic, such as customer arriving in a queue and customer service time. It also has been used in healthcare industry that can be seen in the analysis of appointment system to reduce the outpatient waiting time. Phase 1 is data acquisition. Tracking code or the ID or the creation time, payment time, ship time, and complete time is the only information that were used in this study. 55 data collected from Nils Chocoja seller, while 63 data collected from Melo Crunch seller. There are several assumptions. Firstly, arrival of order in the seller Shopee platform and the arrival of parcel at drop point follow the Poisson probability distribution at a mean rate of lambda customer per day. The discipline used is first come first served basis, which apply the method of which order and complete payment received first was served first. Service time for each customer in both vendor and courier service were exponentially distributed with a mean of new customer per day. Service facility is identical, including the number of vendors for each business and the courier service used for deliveries. No limitation was set on the number of the customer order in a queue, since infinite size of population were applied during the data collection period. All customer order were processed, unless if it being cancelled before payment made. The mean of arrival rate is greater than the mean of service rate. From the flowchart, arrival in the first phase refer to the moment when customer place their order through the Shopee platform. Service start after they make their payment, as seller proceed with preparing the order until seller drop the parcel at the parcel drop point. In second phase, arrival refer to the parcel drop at the nearest drop point. The process from the courier service deliveries to deliver the parcel to the end user is referred as the service in second phase.
Before we proceed to model calculation procedure, the data need to be prepared first. Firstly, the data will be divided into two phases. The first one is service from seller and the second one is service from courier company. Then a few basic calculations were made in each phase to obtain the total number of order in each data and total duration used to serve the customer in each phase from both data. Now, we proceed to model calculation procedure. There are 9 steps in total to be done in each phase in each data. Step 1, obtain the mean of order arrival rate. Step 2, obtain the mean of order service rate. Step 3, determine the utilization factor. And step 4, measure the probability of zero order or parcel in the system. In step 5, we calculate the average number of order or parcel in the queue. In step 6, we calculate the average number of order or parcel in the system. Step 7, we proceed with calculating the average waiting time in the queue. Step 8, we calculate the average waiting time in the system. And lastly, in step 9, make sure to repeat all these steps when calculating the service rate in second phase for both data. For this research study, all the calculations were made in Excel spreadsheet.
In phase 3, t-test is used to validate the results of customer average waiting time for both vendor in phase 2. Before starts the validation, the first step is to find the lambda and the mu for each replication. Microsoft Excel is used to perform the calculation as shown in the table. Next is to validate the results using t-test method. This is the step to perform validation. Step 1, we set hypothesis for H0 and H1. Step 2, we find the mean of waiting time. Step 3, we find the variance. And for the step 4, we find T0 using t-test formula. For step 5, we find the critical value from statistical table using two-tailed test and significant level alpha equal to 0.05. And lastly, we make the conclusion. If the value of T0 is less than the critical value, then we fail to reject H0. Hence, if the value of T0 is greater than critical value, then we reject H0.
This is the result of first and second phase of Melo Crunch. The probability system was used in first phase is 79.32%, while 92.17% in second phase. That means courier service system in second phase may not be able to cope with load if more parcels were added, since their service is close to the maximum. 20.68% in first phase show that system is free, since no parcel or no order to be processed, while 7.83% in second phase. In first phase, average number of order waiting in queue is less than 2, which means 2 order in queue every day. Average customer being served every day is less than 3 order. Average customer needs spend waiting in queue is 1 day for seller complete their order. Overall, in first phase, customer need to spend 2 days waiting in the system. For second phase, average number of parcel waiting in queue is 5.3368, which is about 5 to 6 parcel in process. The average customer need to spend waiting in queue for their parcel is 5 to 6 days. Overall, in second phase, customer need to spend 6 days waiting for whole process to be complete.
This is the result on the effectiveness of queuing model performance system for names Chokoja. As shown in the table, the probability that the system was in use is 66.09% for the first phase and 91.59% for the second phase. This means, for the second phase, the courier service system is close to maximum, where they may not be able to cope with the load if more parcels are added to the system. The remaining 33.91% and 8.41% shows that the system is free since no new parcel or order to be processed in both first and second phase. For the first phase, the average number of order waiting in queue is less than 1, which means only 1 order in queue every day. And the average number of customers being served every day is less than 2 orders. The customer need to spend waiting in queue in less than 1 day for the seller to complete their order. Overall, for the first phase of name Chokoja, the customer usually need to spend about 1.5394 days waiting in the system. While for the second phase, the average number of the parcel waiting in queue is 5.6332 parcel. It means about 5 to 6 parcels were in the process to be sent to the consumer every day. It also shows that the customer need to spend waiting in queue on the average of 6 days for their parcel. Overall, for the second phase of name Chokoja, a customer need to spend waiting in time for the whole process to be completed around 7 days.
This is the summary of validation results. All the test statistic value is less than critical value. Therefore, the customer average waiting time for Melo Crush in phase 1 is 1.4485 days and 5.674 days for phase 2. For NIS Chokoja, phase 1 is 0.8064 days and 6.24 77 days for phase 2.
The total average waiting time in queue for Melo Crunch is less than NIMS Cukup Jauh with 6 days and 7 days respectively. The total average waiting time in the system for Melo Crunch also showing the same result as it is less than NIMS Cukup Jauh with 8.2762 days and 8.803 days respectively. As a result, the vendor encouraged service of Melo Crunch give better services compared to NIMS Cukup Jauh. The customer from Melo Crunch experienced shorter waiting time for their item compared to customer in NIMS Cukup Jauh. It is recommended for other researchers to use a data with a longer period with a lot of queue in a day for a better accuracy of the calculation.